Hello, I'm Simon Thill. I'm from Saranac Lake High School, and I'm here to introduce our first speaker, Dr. Curt Stager. When I was in 6th grade, I had to write an essay about a local hero. Most of my classmates chose one of their parents to write about. I chose Dr. Stager. I wrote about him because, number one, he is a very accomplished scientist. In 2013, he was named New York State Professor of the Year by the Carnegie Foundation. And number two, he's local, and we're extremely lucky to have him in our community. He works at Paul Smith's College, where he is a professor of natural sciences, and he holds the Lewis Draper Endowed Chair in Lake Ecology and Paleoecology. He also researches climate change and environmental history a lot, mainly by studying sediment cores from lakes in Africa and North America. Dr. Stager has also written for many major scientific journals and periodicals, such as Science, the Proceedings of the Natural History Academy of Sciences, the New York Times, and National Geographic. So when my mom found bugs in our spring water, he was the first person she contacted. He responded to her anxious questions by saying they were either deadly Adirondack water poisoning death plague bugs or harmless springtails, commonly found in spring water. How cool is it to have an accomplished scientist in our own backyard? Please welcome Dr. Curt Stager.
This is you. Go ahead.
Well, thanks, Simon. I've got to now not choke up, too. That's really nice. Actually, I was a little bit almost choked up anyway. I hope you all realize that you've already accomplished something really important just by being here and being who you are. People my age and older really need to know that folks like you are here and doing these kinds of things. And when I talk to folks, when I give talks, like I did one last night in town, people were saying, you know, is there hope in the world? And when I talk about the Youth Climate Summits and people like you, it really lifts the spirits of people that need it. So congratulations already for doing what you're doing. So my job for the next 30 minutes is to be your science nerd. I'll be your science nerd guru. As you go ahead and do your amazing workshops and activities and then go back, it's always, of course, important to have the foundations of the science of climate change, you know, pretty rock solid so that you can convince other people of the reality of it and basically empower you. So I've picked some of the juiciest science facts that you should totally make sure you understand when you talk to folks about this issue and then build your actions around it. So we'll just start digging right into it. To sum it all up, you basically just count to 3 of what's going on. It's real, it's because of us, and we can handle it. So to dig into this a little bit, you can be reassured that the science is very solid. You may hear of a climate debate sometimes. It's not in the scientific community, it's out in the public. The actual scientists who study climate change are in amazing agreement that that 1, 2, 3 thing that I just told you about is real. So there are always a few outliers in any community, but 97 out of 100 climate scientists will agree with what we're about to talk about right now. So you can be reassured about that if you hear otherwise. So here's the famous greenhouse gas slide that maybe we should polish this up a little bit. So to summarize it as simply as possible, basically the reason the world is heating up is because heat trapping gases are building up in the atmosphere. And basically what happens is the sunlight comes in and passes right through the air. That's what you see with and things like that. But when the sunlight hits the ground, it warms the ground up. Like you can tell if you walk on a hot parking lot pavement on a hot day or something. Well, then the air on top of the surface of the earth warms up as well. So you get warm air. But the thing is, if you have these greenhouse gases in the air, they trap the heat even more instead of letting it go out to space. So that's the basic idea. It's like being in a greenhouse, kind of. And that's why they call it that. So to repeat it again, the sunlight comes in and doesn't do that much heating until it hits something solid, which is the earth, warms up the surface of the earth and the oceans, and then that warms the air over it. But having the greenhouse gases makes it hold the heat even more. So therefore, the more greenhouse gases you put in, the warmer it's going to feel. So maybe another way to describe it for somebody that's not into the nerdy stuff is it's like wearing a blanket. If you add greenhouse gases like carbon dioxide to the air, it's like putting on a blanket. And the more of these you put into the air, the thicker the blanket is, and you hold your heat in better. So that's one way to explain a greenhouse gas to people. Just say it's blankets around the planet. So where's it coming from? A lot of sources. That can be confusing. You may have heard of many different things. You know, is it cow farts or something like that? You know, well, yeah, it plays a little bit of a role. But first of all, there are many greenhouse gases. The biggest, most important one, though, is the carbon dioxide. So there's methane from the fracking and things you hear about. That's all part of it, or the cows. But CO2 is the one we focus on. That's the biggest one. In fact, a lot of the methane turns into CO2 pretty quickly once it's released. So that's the greenhouse gas to keep focused on out of the many. So the reason the carbon dioxide is building up is because we're burning stuff, and I'll give you the quick list of what we're burning the most of. It's basically industry. In fact, I'll back up there for you. It's if you look to those icons down below, that gives you the list of where most of it's coming from. It's coal-fired power plants, transportation, so burning gas in your cars and trucks and things like that, and industry from factories. And the reason it's coming out is because you're burning fossil fuels, coal, oil, and gas. And when you burn something, it basically takes it molecule by molecule and puts little oxygens on it, and it flies off into the air and becomes a heat-trapping gas. So we've been measuring it in the atmosphere for half a century. So here's a graph of it. You've probably seen this kind of a graph before. If you have, like, these are recent decades here since about 1990 to the present, and here's this bouncy line of CO2 increasing. You may have seen charts like that. So we actually know it's increasing, so the world should certainly be getting warmer. Some people may question, if you tell them that, they may say, well, how do you know that's from us? Well, one of the ways we know it's from us is another gas, which actually might freak people out a little bit if they knew what's going on with this other gas. It's the oxygen. When you burn something, you use up oxygen, right? If you have a furnace, you got to put air in there, or a car to burn the fuel, you need air coming in. So the more fossil fuels you burn, the more oxygen you use up to make the CO2. And believe it or not, we've been measuring the oxygen in the air too, and the oxygen has been declining in our atmosphere the more CO2 we release. So it's basically taking breathable oxygen and turning it into pollution. So you can tell people that, freak them out. You want to suffocate? That's not going to happen. It's actually a very small amount. The reason this is scientifically surprising and important is because it confirms that this CO2 increase is because of us burning things. That's the real take-home message. But you get people's attention when they think they're not going to be able to breathe. So where does it go? A lot of folks think, how could we possibly pollute the atmosphere? The atmosphere is too big. You look up and the sky's there and clouds are high up. There's no way we're going to pollute something as big as that. Well, if you take a bigger perspective and look at the Earth, on a larger scale, the atmosphere is really thin. There it is, that little blue hazy zone. And most of the atmosphere, the thickest part, is just a few miles thick. It's like the skin on a grape, and even less than that, actually. So everything we release into the air is going to stay in here pretty much. And if you do it over time enough, you're, of course, going to pollute the atmosphere and raise the temperature. So you may ask, like, where's it going? Okay, it's going into the atmosphere, but then it goes to other places. So here's like the stuff we're releasing, the fossil fuel stuff. It goes into vegetation and things like that, and then actually it cycles around too. When in the fall, when the leaves fall and they rot, it comes back into the air, it cycles around. Some of it goes into the ocean, and then some of it diffuses back out. So it's kind of equal amounts. But one of the shocking things is that this has effects too that a lot of people don't talk about. You can use isotopes and chemical studies to actually follow this carbon when it comes out of the smokestacks and tailpipes. And one of the places it goes is into this vegetation here, which means when it goes into plants, it goes into the plants we eat. So when you have your nice breakfast, that oatmeal, the grains or things, or anything basically plant-like that you eat, got its carbon, the molecules that most of it's made up of, from the air, because plants breathe carbon dioxide. Well, if it's pollution carbon dioxide, they use that too to make their bodies out of. So when you eat a meal, about 1 in 8 of the carbon atoms in your meal came from a smokestack or a tailpipe. It's contaminating the food chains of the world. It's kind of interesting, which also means if you eat the food, which we all do, you are made of this stuff too. So if you look at your hand or your hair or your fingernails, 1 in 8 of the carbon atoms in your own body came from a smokestack or a tailpipe. Kind of interesting. So you can now tell people, not only are we a source of air pollution, we are air pollution. So it is part of our lives here. We are connected to nature. Maybe not always a good idea. The other place it goes, of course, is the ocean, which covers most of the world. When it goes into the water, it changes the chemistry of the ocean. When carbon dioxide goes into the ocean, okay, it takes a little bit out of the air, that's less of a climate impact, but then it becomes an ocean impact. It changes the chemistry of the ocean so it gets more acidic. And so the process is called ocean acidification. And that's a whole separate issue. Maybe someone doesn't mind if the world gets a little warmer, but they might worry if things are going to dissolve in the ocean because of the chemical changes. So anything with a shell, clams, oysters, crabs, shrimp, coral reefs, all of them are vulnerable to acids, and we're watching the oceans change as well as the climate. So that's another issue to be aware of as well. It's more than just climate change, it's also general change in ecology. So the other thing is the scale of what we're doing is enormous. This carbon dioxide is going to take a long time to soak into the oceans and the soils of the earth. It's very difficult to get rid of it because it's kind of stuck here on the planet. We now know that the amount of time this pollution is going to stay around that we're releasing now is not just our lifetime or our grandkids' lifetime or our grandkids' lifetime. It's thousands of years we're changing the world for. It's huge. It's so huge that if we follow the natural cycles of the earth that make ice ages come and go, we actually know when the next ice age was supposed to come. It'd be like 50,000 years from now. We can predict that from geology. We now know the greenhouse gases we're releasing now are going to be around then too. Just enough to raise the temperature of the earth, just enough that it's going to cancel the next ice age. Now, if you're from Canada, that may actually be good news, right? It's not much fun being bulldozed by ice sheets, right? And here in upstate New York, we get them too, right? The point, though, is look how powerful we are just by going about our lives to change the earth on a geologic scale. So there's a term for this that scientists are using, and you may have heard of this before. It's a technical term for our page in the history of the earth. This time period we're moving into, or we have become a force of nature, is being called the Anthropocene Epoch. The age of humans is what it translates to. Like the age of dinosaurs, the age of fishes, this is the age of humans. Where if you add up all of our impacts, because we're so numerous and our technology is so powerful, we are causing the mass extinctions and pollution, and in this case, the greenhouse gases we're talking about. We're even changing what the earth looks like. If, you know, out from space, the shadowed side of the earth glows in the dark now because we're on it from all the electricity we burn. So just demonstrating, first of all, how powerful we are. Imagine then if we become aware of this, which you're doing, and are empowered to change how we influence the planet we live on. So it's not just, you know, sobering to see that this is the Anthropocene epoch, it's empowering because of people like you becoming aware and now acting with purpose instead of just randomly and doing this by accident. So people may ask you, well, doesn't the weather change all the time? You know, what's this global warming stuff about? It's just weather, you know. Well, okay. Remind people there's a difference between weather and climate. Weather is something that happens here and now, short term. It's rainy here and it's sunny back home today. Climate is different. It's a long-term pattern over years and over large areas. It's an average. So they may not look alike. Remind people that what we're talking about here is climate change. And maybe one way to think of it is when you drive from, you know, the lowlands up into the Adirondacks, The road will have ups and downs in it. Well, that's weather. You get a warm time, a cool time, warm time, cool time. But the overall trip up into the mountains is the uphill trend of climate. And that's what we're talking about. So you don't get distracted by the ups and downs of weather. So just remind people of that if they ask you. So how do we know this climate change is up to us? Okay, you can use graphs to show people, or you can just tell them. You can say there are three things that can warm the earth this much. The sun, which does warm us up, and it changes a little bit from time to time. Volcanoes, they can release gases and dust and things into the air, which can change the climate. And greenhouse gases that we release from fossil fuels. That's basically it. To change the whole planet, those three things. Well, we've been monitoring those three things. We have satellites studying the sun, and we have geologists studying volcanoes, and we have people measuring fossil fuel burning and things like that. So if you have a chart of the last 100 years of temperatures, which we also know very well, you get this black line, some ups and downs, and then it's been warming since about the 1970s. If it were only the sun and the volcanoes, this blue line shows you what the temperature should have been doing if it was only natural stuff going on. It shouldn't be warming. It should be kind of flat. But if you eliminate those, if you add in the fossil fuel burning, then the temperature follows what the real temperature is. In other words, by process of elimination, you eliminate the sun and the volcanoes. The only suspect left standing is the fossil fuels. So we know very well that it's due to us. So hopefully if you can remember that, the three sources, and we've been monitoring them all, basically since the 1970s, it's mostly us. So maybe to put it in perspective, to compare us to the volcanoes, let's say, we now emit 100 times more carbon dioxide each year than all the world's volcanoes combined. We are a force of nature. So imagine how powerful we are if we set our minds to it. We can change the world because we've already done it by accident. Okay, is it happening here? Well, people care about that. A lot of folks want to know, is it? Well, there is. Around here, most of you are from the North Country area, it's definitely happening here. There's a weather station right here at Sun Mountain in Tupper Lake. Here's the temperatures of the last 100 years, and there's a significant increase since the 1970s. It's been warming just like the global picture at about the same rate, maybe even a little faster, starting in about the 1970s. And that's when the human influence really started picking up. When it wasn't the sun or the volcanoes, it's the fossil fuel stuff. So it's all fitting together. We're also getting less ice on our lakes around here. We have ice melt and ice freeze up records that go back 200 years for Lake Champlain. This is a kind of a fancy graph here. The short version is the lakes are freezing later and melting earlier. This one right here, ignore the blue line for now. Here's 200 years of freeze up dates for Lake Champlain. There's early 1800s. Oh, I'm going to back up here. These little black asterisks are winters when the main body of Lake Champlain did not freeze at all. So you can see for the entire 1800s, from here to here, there were only 3 winters when it was a little bit too warm to freeze totally, and then a little bit more, and now bam, 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 bam. It's actually unusual for the lake to freeze in the middle in the winter now. That's something you can see without a chart. That's if you commute between Plattsburgh and Burlington on the ferries, you can see the open ice. So some of us keep nature diaries around here. We've seen the things that happen in spring when the buds open up on the red maples, when the salamanders migrate to their breeding pools, when the native bees come out of the ground. We've been monitoring that since 1990. They're all coming earlier because the spring's coming earlier. Basically, winter's getting shorter. So that's definitely happening here. And our storms are getting bigger. Here's the nerdy chart, but what it basically shows is this is the flood we had from Irene, the storm Irene, down in the town of Keene. That used to be people's backyards. The storms have been getting more intense, so when you get a strong rainstorm, it's more powerful, just like you expect from global warming. So all these things are happening here, affecting people where we live. So the sea level rise story is also part of the story of New York. It affects us here, not in the Adirondacks yet, but down below. So it is definitely real. If people want to know how fast it's rising, it's not going to come in a tidal wave and kill you right away. It's slow. It's about 1 inch per decade. But it's continuing. And it's important. Even that 1 little inch per decade matters a lot if you happen to be in a city nearby and there's a storm surge coming in. So I'll get back to that in a second. But if people ask you, what is it making sea level rise and stuff, there's 2 things. It's the ice on land, like Greenland and Antarctica, that's melting and running into the oceans. And when you warm up the water of the oceans with the climate, the water swells up, like bread dough rising in a bowl. Or like the fluid in a thermometer. As it gets warmer, the fluid swells and rises in the thermometer. So the oceans are rising. About half of the sea level rise is because it's warming, and about half of it is because the ice is melting and running into the ocean. So these small, slow amounts are important if you live on the coast. Like here, a matter of inches can decide whether a hurricane storm surge that comes in is going to flood the subways of New York or not. It either does or it doesn't. And it turns out when Hurricane Sandy showed up, the damage was much more severe than it would have been if we did not have the global warming going on and the sea level coming up. If it were the sea level was where it was, 200 years ago, we would not have had nearly the damage. So these little inches do matter too. Some people will tell you it's not due to us, it's just natural cycles. That's the research I do, and my colleagues and students at Paul Smith's college study these kinds of things, and we know it's not the natural cycles. If you look at sediment layers under lakes in the Arctic, which are now opening up and melting in the summer for the first time, we can actually see signs of that in the sediment under the ponds. And you may not have heard of this, but basically, some people might say, well, every time you get a natural warming cycle, these lakes will melt, and what's the big deal? Well, we have the sediments from under here that go back thousands of years. And there is no sign of melting at any time in the thousands of years history of these lakes. This is the first time in geologic history this has happened in the Arctic to be that warm. And, in Antarctica and the ice cores, you may have heard too. So we also have the geological records which tell us it's not natural cycles. So I'm just skimming through these, but I'm just reassuring you, what you've been hearing is correct, and these are the basic summary facts, which you can look into in more detail. So you can also tell people, why should I care? If they ask you, why should I care? I don't care about polar bears. They eat people anyway. Maybe it's good they're going away. I don't know. If they're just up north, I don't care. To empower yourself to get the best info, to respond to questions like that, I recommend 2 websites. So you might want to sketch these down. You can Google them. They're easy to find. If you want background stuff, pictures, some of the nerdy science, one of the best places is called Climate Central. So I recommend that. Another one, if you really are into nerdiness, and you want to build a story about where you live, which is a more powerful way to get these messages across, to get the weather records or the patterns or the future for where you live, Climate Wizard is a good one. If you're a little savvy with this kind of thing, it gives you visual charts of not only the climate changes of the last 50 years, but also where it's headed by state, by country, or the whole world. And you can pick different time frames and things like that. So you can look up what's likely to be happening where you live and use that to tell people, maybe in your climate action plans. So I recommend that. Like in our case, we're worried about losing winter. It not only bothers us because we like being outdoors, but it's part of our economy as well. So that makes your message more powerful if you bring it home to where you live. So the other thing is to remember, don't get too depressed by all this stuff. I just spent, the last 20 minutes trying to show you how serious this is, right? And you already know this. But remember not to just curl up in a ball. This is not the time to be so depressed you just give up, because a lot of people do that. Now's the time to take action. And I know your generation is an inspiration to the rest of us that are older, because you tend to see this as the great challenge of your generation. And there is cause for hope because you are here doing what you're doing. So remember, you are a force of nature. We are so numerous, our technology is so powerful, and we're so interconnected. We change the planet. You can also change society. So you may say, oh, what can I actually do? I'm just a small person. Maybe I'll change my light bulb. Maybe I'll recycle more or something. It's like, okay, that's not going to change the whole planet just because you use a different kind of light bulb or something. But what it does do is it changes you when you do these small things that mean something to you. Because it's a reminder that there's an important thing going on in the world that you need to be aware of and that you're working hard to help change. It's like a little ritual, a little reminder daily of what you're doing and why, as long as you know why you're doing it. And the other important thing to remember is you have a sphere of influence. Just by being yourself, you may not realize, but people watch you and see what you're doing, and they listen to things you say, and they may not even tell you they're paying attention to you, but they notice what you're doing, and you influence people just by being who you are and having your lifestyle. So, just something as simple as supporting the good science, getting the facts down straight so you can make a good and be empowered to make a good, convincing argument to somebody that's maybe sitting on the fence on this. Or, when you're old enough to vote, do the voting, or support with your money, or your words, or your lifestyle. Just do as much as you can, and this is one of the ways you can do it. So what I like to do is wrap up with a kind of a fun exercise of how individual people can work together to make amazing things happen, and to sort of represent this great wind of change that's coming over the planet. So what I like to do is have us create a rainstorm in the room, which is lots of fun. So the way I'm going to do this is I'm going to walk on the stage back and forth across the room, and I'm going to make a motion for you. And I'd just like you to copy it as I come past your section of the room, and just keep doing it, and then I'm going to come around